All right. So here it says you are given a graph of f prime. Sketch me f. If f prime is a constant, what does that mean the function before it was?
Linear.
And what does that mean the slope was? So that means that a possible graph of x is 2x plus some y-intercept. So you don't know your y-intercept. So as long as you draw a graph with a slope of 2, it doesn't matter if you go through the origin. It doesn't matter if you go through -2. All that matters is that you go and follow the slope rule. Make sense? Okay, next way, if you are given a linear, that means that the graph before it was, yep. So this is y equals x. So that means this is like y equals x squared, again, plus some number or y-intercept. If you want to be normal and just go through the origin, then you have 0, 0, 1, 1, and then remember 2, 4, because the y's are all your perfect squares. Now, this is a derivative graph of negative x squared. You kind of know that, right? So this is y equals negative x squared. We can figure that out because we can see it. So we know that the function that comes before it is going to be something like cubed, but again, all that stuff happening after. So if you do your analysis, if the derivative is increasing and negative, then your original graph has to be what? Concave up and decreasing. So again, if f prime is negative, then we know that we are decreasing. If f prime is increasing, then it's concave up. So I would almost have like my concave up, concave down, my increase, my decrease, and f prime of x equals 0 down here in my analysis, because that will give me the intervals of importance on my original. So it's negative from negative infinity to -4, so that means this graph is decreasing. It's 0 at x equals -4, and if it goes from negative to positive, it's decreasing to increasing. So that makes this a min. And then it's decreasing. It's positive from 4 to -2. So that means that this is increasing. X equals -2 is a 0. So it goes from positive to negative, so increase to decrease, making this a max. Next critical point is at x equals 4, and again it changes signs, so that makes it a min. And they told you -4, 2, which is a min, is at 2. So I know to the left of that it's decreasing. And then because this is increasing, it's concave up. So I'm going to be concave up until about -3. And then at -3, my graph changes to concave down. but it stays increasing until -2. So then -2 becomes my max. And then it changes back to decreasing, but it stays concave down until about 1. So for me, I'm going and doing something like this. So I have my concave down to concave up. At 4, I have my min and then my increase. Now again, you could be higher up, you could be lower down. It really doesn't matter. Or you could go in and figure out the steepness, but it's not asking for that. But it did give you that passing through point, so you do want to make sure you plot that. Okay, let's go to the back page where it has like a different setup. So on the back page, it has sketch a possible graph with these given functions. So now you don't know the derivative, you just know what the derivative or the second derivative are doing. So for example, if the derivative is positive, then f of x has to be what? No. So if the derivative is positive, f of x is increasing. Does it have to be greater than 0? So if f is positive for all x, then f is increasing always. The second derivative is positive for all x. So if the second derivative is positive for all x, f of x is both increasing for all x and, yeah. It passes through 1, -2. So think of like an exaggerated, kind of like quadratic, but only the concave up side and from like the minimum. Because like eventually my thought is it probably like tears off and has a horizontal asymptote, but we don't know it. So what I want you to do is your homework